Okay, so this is the mock AP exam 2020. This is number 2 off of the mock exam number 2. We have a function that's defined as e to the x minus x. Part A says find the critical values of f. Classify each as a relative minimum, relative max, or neither, and then justify your conclusion. So to find critical values, we first have to find f prime. From f prime, we can set f prime equal to 0, solve for x, and then from there we can create a f prime sign line to see if there's a change in sign to help determine if there's a relative max, relative min, or neither. So f prime, we're going to go through our derivative rules here. E to the x becomes e to the x becomes 1. We set our f prime equal to 0. We solve for x. We get e to the x equals 1. I want to solve for x, which is sitting up in the exponent region. So the way we can bring it down is we can introduce natural logs to both sides of the equation. We say natural log of 1 is equal to natural log of e to the x. Bring the x down in front. Natural log of e is 1, so x equals 0. We place 0 onto our sign line, and then we test points on either side with f prime. So plug negative 1 into f prime, we get e to the negative 1 minus 1, and that will give us a negative value. So e to the negative 1 is 1 over e minus 1. It's going to be a negative value. Okay? We can plug 1 into the derivative, we get e to the 1 minus 1. That's going to be e minus 1, which is a positive value. So we know there's a relative minimum at x equals 0 since f prime changes from negative to positive. Part B, write the equation of the line tangent to the curve at graph of f at point where x is equal to 1. So tangent line equation just requires us to find the order pair and the slope. So the order pair we can find by plugging 1 into the original function. So e to the 1 minus 1 is just e minus 1. The slope, f prime of 1, plug 1 into the derivative function, which is e to the 1 minus 1, also the same value. Okay, so we have our order pair, we have our slope, and we just put into our point slope form. Okay, y minus y1, y sub 1 equals m times x minus x sub 1, so y minus parentheses e minus 1 equals slope e minus 1 times x minus 1. For part C, given the definite integral from 0 to 1, f of x dx equals f prime of a, find a. So here, what we can do is we can replace f prime of a with the derivative and plug a into it. And then on the left side, we can replace f of x with e to the x minus x and go through that process. So when we do that, we get e to the x minus x squared over 2, plug in our upper and lower bound. We get e to the a minus a squared over 2 minus parentheses, plug into 0. So careful with 0. 0 doesn't wipe everything out here. There's going to be some remaining term here. E to the 0 minus 0 over 2. Now this goes away, but not this e to the 0. So we take the result of the definite integral. We set it equal to the e to the a minus 1, which is what we found on the right side. So we make the appropriate substitutions on the left after we've cleaned this up a little bit. E to the a minus a squared over 2 minus 1. And then once we have them equal to each other, combine some more like terms. The e to the a goes away, the negative 1 goes away. We're left with negative 1 half a squared equals 0. We solve for a, we get a is equal to 0. All right, part D, suppose y squared f of x equals y minus 4. Find dy dx. So look at how this is set up here. We have to go through product rule. There's also implicit involved here because we have y's involved. So we're going to find the derivative going through product rule first. So f prime g plus f g prime. Replace, let's see, y squared becomes 2y dy dx. F of x stays. Back to f here, we keep the y squared. G prime becomes, take the derivative of that resulting expression, so f becomes f prime. The right side, y minus 4, y becomes 1 dy dx, and the 4 goes to 0. So we have our derivative, we just have to kind of rearrange it to solve for dy dx. So we're going to group the terms on the left side. Group the dy dx terms on the left, move the non-dy dx over to the right side. Okay. Factor out the dy dx, divide the parentheses over, and then our final step is let's replace all of our f of x and f prime with the exact expression. So f prime is e to the x minus 1. We found that from previous parts. F of x is just e to the x minus x. So we can either leave it in this form or we can distribute everything out, and either answer would be fine. An adjustment with the points here. Number 2 should be 1 point, and then part D is going to be 3 points. Okay, so 2, 1, 3, 3.